Okay, fine. Thank you very much for just being a patient for last 20 to 25 minutes, because some of the issues with my system also wanted to update Zoom, all those things. No problem. Now that it has been solved, we will just go inside this subject. Okay, so that's what I'm going to do. After that, let me bring my writing pad close to me. 1 minute, because there's some glare is happening. I will light, I will switch off. Okay, good afternoon. To actually this semester we are going to, as per this myself is concerned, this course we are going to see, it is one of the most important course. This course I am teaching for last 22 years for IIT, BTech, MTech and PhD scholars, and very important course for student from not only mechanical, even for other department, electrical, computer science. Because right now I'm teaching course for regular course also for my as a our BTech, MTech, all those things. I get students from BTech, MTech, PhD from various departments, mechanical, aerospace, ocean engineering, electrical. All these students are attending my course, because now we see most of the machines or systems or devices you see across your home, your office, or in the factories. All those things are what you call as a mechanical system, which are controlled by electronic circuit and software. That means software means you need a computer, then control all those things. That's what's going to be there. That's why this course became more important. Okay. Uh, as per this is kind of what is a mechatronic system or mechatronic product is, or mechatronic engineering. You can see that from uh, this one, this slide, we can see the mechatronic system is nothing but engineering, nothing but fusion of various engineering discipline. Correct. So what it mean? Fusion of engineering means, you know that, well, if you join engineering institute, even before joining, you'll be asked to select the branch in which you wanted to learn. Correct. Engineering discipline, there are many different branches, starting from mechanical engineering, civil engineering, electrical, electronics, computer science, information technology, aerospace, like that, metallurgy. There are many engineering fields, correct? Maybe around 10 to 20 to 30 also, depending upon institutions. But fundamentally, you see 5 to 6 engineering. We call it basic engineering, mechanical, electrical, civil, and also electronics and computer science. Okay. So if you wanted to make a mechanical product, a machine, you are supposed to learn mechanical engineering, which teaches you how to make a machine. Machine may have many components, correct? Individual component like bolt, nut, link, joint, gears, correct? Like many parts, depending on the type of machine. Then how to make that individual component, we call designing. What material to use, all those things you will learn in the mechanical engineering. That's what you will teach. You may to study some 30 to 40 subjects starting from first years, correct? Later then you go for many this one. Suppose you go to electrical engineering, you will start up a electronic component like transistor, correct? diodes, resistor, capacitor, all these things. Then circuit design, then IC design. Then the electrical student, we talk about generator, motor, transformers, transmission lines. Like that, you may study around 20 to 30 subjects. Similarly, when you go to civil engineering, they talk about building materials, correct? How to design architecture, correct? Then like how to construct building, what is a concrete, like that, relevant subjects. So like that, basic engineering there. Now, since we are talking about mechatronics, let me show the next slide. It is called a fusion of various engineering. Okay, mechatronics is called as multidisciplinary engineering. Mechatronics is a multidisciplinary engineering which rejects splitting the engineering into separate disciplines. Generally, as I told that, if you study mechanical, they'll teach only mechanical subjects. You can design only mechanical products. Correct? It can be a machine itself, for example, CNC machine, lathe, or a bus, car, all this, correct? A missile, rocket, a ship, correct? A conveyor belt system, or in fact, you use robot, all these things. All these things are made up, called mechanical machines. This machine you are going to make, but you may not know about electron also because you are not studied. But some 50 years before, if you see a car, automobile, correct? What you see, if it is a petrol car, you will have a petrol engine, correct? Then it will have a gearbox, one transmission system, a body, correct? All which where it is assembled, a steering system. That's it. In which you may see one or headlamps, tail lamps, and interiorly maybe inside your cabin a small light. Nothing more than that. If it is a diesel engine, to illuminate your dashboard. Nothing more than that. If it is a diesel engine, if it is a petrol engine, diesel engine. If it is a petrol engine, you have spark plug and high tension coil. All those things create the sparks that also get power from, all these things get power from a battery. You have a 12 volt, correct, lead acid battery or 24 battery, from which you have they will be connected to sparking system, ignition system, which are high tension coil, all those things, circuit breaker which generate high voltages. Then you have headlamp, tail lamp, and if the car multi-cylinder engine, fuel pump may be there to suck the fuel from the tank and supply to carburetor. That time fuel injection was not there, correct? Diesel engine had an injector, but petrol engine only carburetor. So these are electrical things. No electronics, no computer, no sensor, no ECU, no program, nothing. You see, even now old generation cars, so you can see, correct? Maruti, I am talking about Premier Batmini, Ambassador car. Even you go to US also, Oldsmobile, old cars are there 30, 40 years before car, correct? You talk, but this one doesn't need any help from other type of engineering, electrical engineering, computers, nothing was needed. But now we are having a machines. If we talk about car, you have fuel injection. Fuel injection, there's a ECU, there are a lot of sensor, there is an injector, which is called actuator. There's a stepper motor, a servo motor, which open throttle close as well as per demand from driver, correct? And all these things are electrical, electronic sensor. Then sensor, lambda sensor, airflow sensor, temperature sensor. These are connected to ECU. In ECU, write programs which read this information. Based on the program what you read, it may control fuel injection using pulse width modulation, correct? And control the throttle by controlling a motor, correct? Throttle valve motor. So the engine responds to driver demand as per your when you press the throttle. So the engine now become electronically controlled. Old generation Ambassador, there's no fuel injection, only carburetor. Carburetor, throttle valve and needle valve are controlled by your accelerator. If you press, needle valve opens, more fuel comes in, the throttle opens, more air, so that they mix, they form air fuel mixture and goes inside the engine. Diesel engine means when you press, the injector opens the fuel at the appropriate time during compression stroke, there is a diesel burns and do. That's what was there. Then you talk about steering system. Steering was manually controlled. Driver turns the steering wheel by applying torque using his hand. That is transmitted to rack and pinion mechanism, which in turns your front wheel of the vehicle, so the vehicle can steer left side, right side, depending on how the driver is there. So there's no electronic sensor, nothing. Similarly, brake also, mechanical brake with a drum brake, something like that. or hydraulic brake, absolutely no electronics. So that is we call a old generation car. So that is an example for conventional machine, correct? That is called a conventional machine. But nowadays, all the machines, whether it's car, bus, or aircraft, or a submarine, or this one, we see, or a CNC machine, or a robot, washing machine. We are going to see that washing machine also mechatronic device only, right? Then camera, automatic camera, all these things are mechanical system which are controlled by electronic circuit using software and control algorithms. So that means in mechatronics we are trying to integrate various knowledge from other engineering fields to make a product, because product itself not pure mechanical product. All the mechanical products are now electromechanical with automation, control system, all these things. That means you need to integrate all these things together, okay, so that you will be able to uh, control your machine, correct, for better performance. Why you are doing electron, all this thing? You want to improve the performance of your fuel efficiency of your engine, braking, reducing braking distance without spinning the wheel, or anti-lock braking. Steering, you wanted to smoothly steer without much effort by the driver, because most of the steering effort is given by the motor assisted steering, correct? It can be hydraulic, all those things. So the word, when we want to talk about this, the word mechatronics was coined by an engineer who was working in Japan, Yaskawa Electric Corporation in Japan. His name Teshuri Mori. Correct? You can see the name Teshuri. 1969. He coined the word called mechatronics. What is mechatronics? Mechanical controlled by electronics. That time computer are also very little, but electronic circuit was there. Correct? Using electronic circuit, you can automate some part of the machine. So that's why he called as mechatronic. Mecha plus tronics, say mechatronics. Before that, this word was not there. He coined this word in his local language, maybe Japanese language, but the translation was called mechatronics. Okay, that's how it was there. After that, it is getting popular. Okay, now, before going into mechatronics, I just wanted to talk few things. What you call as what is a general mechanical design, conventional design. I'll just take another 2-3 minutes because I wanted to stop by 5:50 so that you can take relax and attend next class. We lost today class, that I will compensate. Okay, by
Okay, sir.
some other.
Not a problem. Not a
Okay.
problem, sir.
Okay.
Time, sir.
Yeah, fine. Okay. Now, before talking about mechatronics, I want to talk generally how will you do your mechanical design some 50 years before. Because later we are going to next class or within 1 or 2 class, we call mechatronic design. What way to design by conventional design or mechanical product? For example, 50 years before you want to make an engine or you want to make a new steering system. What you do, first thing is you have to get existing steering system, you want to design new, means you have to get an idea. What is the new steering system? It will be different from existing mechanical system, because steering is a mechanical system, which I am talking 50 years before. And even now, main part is mechanical. Only control is done by computer and software, all these things. So you have to get a new steering mechanism idea. So you got it, get the idea. What is next step? Product design. You say once the idea is there, then you will design a product. What you do? First, you have to design what are the components. Correct? What should be shape of individual components? Correct? Steering wheel is there, steering column is there, rack is there, and you wanted to have different type this one, what will be difference? So what should be shape of individual components of steering system or a gearbox? Correct? So you want to design new gearbox, whether it is uh, type of gears, correct? You have spur gear, correct, and different type of gears. What type of gears? How many gears you need? What should be dimension? What should be gear ratio? All those things you design. Shape. What material use? Whether you use aluminum or, because gear you will not make aluminum for a vehicle, correct? Where more wear and tear will be there, high load carrying capacity is needed. All this thing you will do based on you select material, and then uh, individual component design, correct? Individual components you will make, what should be individual component, what should be shape, what material, like that you have to do. Then what process you have to use, correct? At design stage, I am talking product design stage, correct? So whether you need to use lathe or a milling machine or a shaping machine or some other machine to make the individual components, correct? Gear cutting machine, shaft you have to, turning machine you have to do, lathe you can use. Then you design, they call product design. After that, you generate individual parts, make a drawing. I'm talking 50 years back. What do? You go to the draftsman, correct? You give hand sketch, and what's the dimension of rod, length, diameter, what material, what is gear pitch, number of gear tooth, correct? Other rack mechanism, all this thing, make a hand sketch, give it to the draftsman. He makes the part drawing, accurate part drawing with the dimensioning, all these things. So clear drawing, that drawing will be, that is called generating part. The drawing will be given to the workshop. So from design stage, the first is two step, correct? Product design, deciding material, shape, all those things, then generating the drawing, all those things you are making. This will be given as a, we call engineering drawing. This will be given to the machine shop, correct? In the machine shop, you give it to supervisor or manager, and he will give the individual parts, the part drawing to individual operator. Somebody, some product you have to make it to milling machine, some product you have to use lathe, some product you have to use shaping machine. You design and give the drawing to the appropriate operator to make the parts, individual part, called prototyping. You make individual components, then you will be assembling. Once individual components are made, you will assemble it, or you go to next step. Product is called prototyping. This is not going to be immediately used in the actual machine or actual product which you get seen, because you are trying to make a new product. So individual components are assembled, subsystem or assembly is made, that will be go under testing. Many times generally they do individual components, they will test whether it can be. For example, you take a bolt and nut, you want to test how much really, when tightening the nut, whether the bolt should not shear, correct? What should you load it can be, all those things you test it on the test bench by connecting to all those. Or you may do go to universal testing machine, apply compressive load or tensile load, and see whether it withstands the forces, load carrying capacity, all those things by testing. Once individual component tested, next thing is you assemble the components. If everything, so everything okay, you will assemble the components. Then the assembled components will go for again full testing, subsystem. Once that is done, you test the entire machine. Testing will be done individual components. If there is some problem, what you will do? Again, you go back to redesign. Redesign means product design. So you go to design. We say go to drawing board. That is in factory, correct? If product fails, you go to again drawing board. Again, you make the material, what failure, material due to material or shape, dimension of the material, change the dimension, all those things. Again, you generate part drawing, again make the individual components, you will go. So once product goes through testing and successfully complete testing without any failure, then you make the product launch, last step, make the component and start selling this one. This is conventional design. Main thing what I want to tell here, just I will just 1 minute I will take here. The conventional design, each and every once you get the idea, make a drawing, make the component, physical component you have, which is called prototyping. Individual component you have to make, then assemble the component, and the individual component you will test. If fails, again you make one more. Every time you make a bolt, for a bolt and nut, you tighten it in the test bench, it fails, correct? It shears. What do? You change material. Instead of aluminum, because dimension, for example, length is 10 centimeter, diameter 1 centimeter, correct? You made it for example, aluminum, correct? So, and when you test, it shears because the load is more. Then what you do? There are two options. You can increase the diameter. If you want the same aluminum material, what you will do? You will increase the diameter of the bolt, correct? Raw material. Instead of 1 centimeter dia, you take 15 centimeter dia, make the bolt, correct? Then again do the testing. Again it fails, correct? You guess only, exactly, because that's what I said 15 years before, correct? You do testing, all the fails, again make. So every time you have to make a new drawing, correct? Start from shape, then making drawings, and going make individual lathe or which machine you have to work on the machine, raw material, take raw material test, and you have to do. Then it fails, correct? So this is time consuming. This is conventional design. This is going to take a lot of time. correct? So product development cycle, this is what you use in company, all of you know, correct? You want to be the product developer very small, but the conventional design takes some time depending upon the complex of machine, maybe 1 year to even 5 years. You want to make a new aircraft or new jet engine or new car. I'm talking 50 years before or 40 years before mechanical design. So that should be, that nowadays is replaced by virtual designing or modeling simulation. I stop here. You could join the next class because faculty may be waiting. We will start tomorrow from here.
We have put that present in the chat box, sir.
Okay. Yeah,
Okay,
all of you put chat box present because that is taken as attendance. For new students also, there's a chat box. Correct. In the chat box, you type your name and roll number.
Sure.
Present you put. You put a present, that is sufficient. That is taken as attendance. For new based students, they may not know. I'm giving in your screen. You will see that chat box where you enter. I think I see 35. All of you. See you tomorrow by 5 o'clock again in the Zoom meet. I may send a new Zoom meet. Please wait for it. I may use this or I may create new Zoom meet. Tomorrow I will send all of you again. Okay. I will decide tomorrow and look for new Zoom meet which will be controlled by me directly.
Sure, sir. Sure.
Okay.
Thank you.
See you tomorrow by 5 o'clock. Good luck.
Good luck.
Thank you.
Thank you.
Thank you, sir.